Welcome to a presentation using the equation editor software MathCast. This is number 6, equations of motion in MathCast. So let's have a look first of all on a screen I've got here. On the next screen we have a parabolic curve. So when you fire an object up at a velocity of u at an angle theta to the horizontal, you've got a parabolic trajectory here, first of all too steep, and then on the right saying too shallow. So u and theta. So let's have a look as to writing equations of motion. And we're going to bring up MathCast, edit screen, and first of all we're going to type in, let's do plus. So ux equals u cos theta. I'm going to go down the bottom there and type in theta. Now ux, that's in the x direction. I want the x's to be a subscript. So if I type in by the x, if we do that, now I've got ux equals u cos theta. If I then click on that, Control C, copy, and then add another line, I can now change that to u y equals u sine theta. Now I've got these two. So first of all I'm going to click on that and show you Control C and then go back into that page. So I can put ux down the bottom there, ux equals u cos theta, bring back the screen, uy, uy equals u sine theta, and then we go back into the program here. Let's get into these, the most common equations of motion. For example, add another line. So the most common one, of course, is velocity is distance divided by time. Pretty straightforward. Velocity is distance divided by time. Now I'm going to look at to get an average velocity. So you do v average equals s average divided by time. Now of course that doesn't look anything like it should do properly, so I need to put the subscript here, and then because these are letters, want them no longer italicized, we're going to put the speech marks there, and then we're going to do the same with the s, subscript, speech marks, and do that and see what happens there. That's pretty good. V average equals S average divided by T. Then you can type in that again. To save you doing all that again, you can Control C it and then add Control V and just turn it round by doing this equals that times time. Now of course an average of a velocity is the initial velocity plus the final velocity assuming constant acceleration divided by 2. When you take an average, you add the two factors together, the beginning and the end, divide by 2. So I can take that and then keeping each line as we go along. So I can now have bracket u plus v divided by 2 times t. How's that look? Yeah, not too bad. Let's make it a little bit more explicit really. You can do the left hand one there, and then we can have the right hand one there, and then put the bracket there. There we go, that looks better, doesn't it? So the average displacement is u plus v divided by 2 times t. In fact, we just take the times off and just do that. So I can Control C that one, put it onto the screen, put it up the top there. Let's get some more equations of motion on now. So you've got the v, the definition of acceleration is v minus u divided by t. How does that look? Oh, not good. Want it on the same line, so we do our left one and our right one. There we go. Acceleration is v minus u divided by t. Control C that. Put it on here on the screen again. And then we can go, the more common way of writing that is v equals u plus a t. Control C that. Put it into there. And then you've got the other equation of motion. You've got your v squared equals u squared plus 2as. How does that look? No, it's put it as a suffix, so I need to change that to a squared, and that one to a squared. There we go. V squared equals u squared plus 2as. And then we can have, it's the beauty of doing it PDF, you can just move these equations around, you probably see. And then we have s equals ut plus 1/2 a t. Getting the hang of the now the power squared. S equals ut plus 1/2 a t squared. Control C that one and put it into there. So you can put them all around. You can move these. They're very, very easy to use. On PDF it's great. Word it's just a little bit more defined. You have to put it on the command line of a Word document. PDF file, so easy to do. So I can just put these all over the place. I can move them around. I can put that one there. That one there. You can change the size, make it bigger if I wish. Doesn't look good. Don't really like doing that. What about changing the color? Let's change it to black. And then import that one into there. Put alongside, it looks quite nice and black. I do like it in blue. I think I used blue for my marking one. Didn't like marking red unless it was a catastrophic error. So you can have it that way, and then in black, but you have to change. If you want to do it for every equation you type in, you have to change the settings. But let's put in some value. Let's put in some values. Acceleration is g, which is 9.8 meters per second to the -2. And we know from last time that it doesn't look very good. You have to start putting in quotation marks and spaces, and a space between a meter and a second, and then a quotation mark here to finish off with, raised to the power, and because there's more than one item, it's to the power -2. Happy days. A is G is 9.8 meters per second squared. Control C that. Put it into a screen, wherever you like. There we go. So that's the image is courtesy of S207, one of the modules I taught with the Open University. Physics, you've got projectile motion, you've got all these equations of motion here. The power of doing it with MathCast, we can now save it as into my file. Save the whole lot here. Once it's typed up, of course, you can use it many times after. We're going to do example number 2. Equations of motion. Equations of motion. Next time we're going to look at trigonometry. I save the file now, and I can just take it and adapt it. So it's very, very powerful. So next time we'll look at the trigonometry, angles, that kind of thing. So finish off. Now this is number 5, and here's a link to the Open University Digital Archive. Very much worth having a look at that. Number 6 actually. Didn't change the number 6. There we go. Thank you for watching. Take care now. Bye bye.